Today we're going to prove and use something that you probably already know, which is what the measure of the angles in a triangle add up to. But then we're also going to apply that to a new type of problem so that I can shave off a couple steps when a problem looks a certain way. So first what we want to do is connect this with the parallel lines that we've been doing. And so we want to show that what happens with the inside angles of these triangles coming from parallel lines. So if you look at this and you think about your angles, if this whole angle is 140, then that means that angle 2 is 40 degrees. And if I do my Z for my alternate interior angles, then that means that angle 10 is 40 degrees. Then if I look at this whole thing is 120, and I do a kind of more elongated Z, then I have that angle 12 is 120 degrees, and angle 11 is 60, which we also know that means angle 8 is 60 because those are alternate interior angles. So if I look at the angles in my triangle, they are adding up to 40 plus 60 is 100 plus 80 is 180. So by using alternate interior angles, we can see that the angles in a triangle add up to 180. So we're going to do an actual proof of that. So we always start with our given, so I'm given that particular triangle. It's kind of a boring given compared to what we've done. So we have triangle, and we literally just draw a little triangle. Triangle ABC. That's what I'm given. And what we're going to do is we're going to use something called the parallel postulate. The parallel postulate just means that if I want to go through point R and draw a parallel line, there's only one possible parallel line that's going to go through R, and we're using P and Q here. So we're going to do, let's just call that parallel line M. Construct M parallel to line PQ. And we can do that from the parallel postulate. And I'm going to add in a couple other numbers here. So I'm just going to call this angle 4 and this angle 5. So one thing I know is that angle 4 is congruent to angle 1 by alternate interior angle theorem. I also know that angle 5 is congruent to angle 3. And that's also alternate interior angles. I know that the measure of angle 4 plus the measure of angle helps if I turn on the pen instead of the eraser. Measure of angle 2 plus the measure of angle 5 equals 180 degrees. And that's because they are forming a line. And then basically we could go through and talk about how that means that the measure of angle 4 is equal to the measure of angle 1, measure angle 5 is equal to the measure of angle 3, and that's just the definition of congruence. And then by substitution, I can conclude that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So that would all be by substitution. All that to say something that you've already been doing, which is the sum of the angles in a triangle is 180. So let's look at that in a few problems. So we have some of these. So basically, if I have all the angles in a triangle, I know that all the angles in a triangle add up to 180. So x plus 57 plus 65 equals 180. There's a lot of different ways that you can do this on the calculator. You can subtract them one at a time. You can add them and then subtract. Just be careful if you're trying to do it all at once that you're putting parentheses around stuff. So I'm just going to subtract those over, and I get x is 58 degrees. Don't worry about the part about the sides. We'll talk about that later. This symbol, remember, means it's 90 degrees. So the sum of the angles in a triangle are 180. So 40 plus 90 plus x equals 180. So x equals, I was about to write x equals again. X equals 50 degrees, because this is x plus 130 equals 180, and subtract it over. Now we actually get into some ones where we have to do a little bit of algebra. So I have all the interior angles of my triangle. So 8x plus 2 plus 60 plus 70 equals 180. So 8x plus 132 equals 180. 180 minus 132 is 48. So x equals 6. Solve for the value of x and list the sides. We're just not listing the sides right now. We'll talk about how we know what is the biggest side later in the course. Add up all your angles. Those are going to equal 180 degrees. So when I combine like terms, I get 2x plus 60, 70, 154 equals 180. 180 minus 154 is 26. So x equals 13. So that seems probably pretty basic, and you've done problems like that before. But now we're going to apply it and do something called the exterior angle theorem. So my goal is to prove that these two angles, 1 and 2, are actually congruent when I add them to angle 4. That's what the exterior angle is. 1 and 2 are called remote interior angles, and then 4 is called an exterior angle. So this is asking me to show that exterior angle is equal to the sum of the remote interior angles. Alright, let me erase all that stuff I've written on here. So since we've just proved that the angles in a triangle, the measure of the angles in a triangle add to 180, I can now use that fact. So if I'm given that picture, I know that the measure of angle 1 plus the measure of angle, I cannot write this morning, plus the measure of angle 2 plus the measure of angle 3 equals 180 by the triangle sum theorem. Now I can help to look, where do I want to go? I want to go to measure 4 is measure 1 plus measure 2. So I already have measure 1 plus measure 2. So what would help is something to do with 3 and 4. Well, if you look at 3 and 4, what are those making? Those are making a line. So I know that the measure of angle 3 plus the measure of angle 4 equals 180 because they are linear pairs. Remember, when they form a line, it's called a linear pair. So the linear pair theorem lets me say that they add to 180. Linear pair theorem. Now you look and they both are equal to 180, so what property can I use? I can use the transitive property, measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. So that's the transitive property. And I'm almost there. What do you notice? Whoops, I lost a measure of angle 3. What do I notice I have on both sides when I remember to write it? I have a measure of angle 3, so we can subtract that from both sides, and now we're left with measure of angle 1 plus measure of angle 2 equals measure of angle 4, which is where I want to end up, and that was just by subtraction property. So the sum of the measures of the remote interior angles of a triangle is equal to the exterior angle, or the measure of the exterior angle, really. So when I do it with just numbers, then some of you will think that it's really not necessary because you could do this kind of domino effect and find one thing and the next. But once I start adding in variables, it gets harder to do this when I start adding variable expressions. So what our thing means, you want to make sure that we're talking about if I extend out that side of the triangle, this is called my exterior angle. So the other two angles on the side that are not touching that angle would be this. So 50 plus x equals 120. And then we solve that equation. So x equals 70. Same thing here. We have x. We have the 90 degrees and the 70 degrees. So 90 plus 70 equals x. So x equals 160. So right now you think this is a pretty pointless theorem. But now when I get to a more complicated thing like this, it would be a lot harder to try and do the type of reasoning you might have been using. So I know that the exterior angle is equal to the sum of the remote interior angles. So 5x plus 10 plus 58 equals 11x plus 2. So 5x plus 68 equals 11x plus 2. So 6x equals 66, and x equals 11. Same thing for the next one. The sum of the remote interior angles equals the exterior angle. And I just noticed it's asking us to find y, but I don't really know enough about this to find y yet. So I'm going to find x first. 30 plus 10x minus 10 equals 12x minus 4. So 10x plus 20 equals 12x minus 4. So 24 equals 2x, and x equals 12. So my way of doing this is I'm going to substitute in 12 to my red angle here, and then find the supplement of that. So that would be 144 minus 4, which is 140. So if that angle is 140, that means that y is going to be 40 degrees. I also could have substituted it in the interior angle and subtracted from 180 as well. That's it for that.